Welcome for this analytical chemistry practicals. Today we are going to estimate amount of persulphate in the given solution by back titration with standard ferrous ammonium sulfate solution. Basically in back titration method, in the unknown solution, in this case it is potassium persulphate solution, we have to add excess amount of Fe2 solution. Part of the Fe2 will be consumed by the sample solution, that is persulphate, and excess Fe2 plus can be back titrated against KMnO4 solution, 0.1 KMnO4 solution. So this is called as back titration, and this is the basic principle of this estimation. Now what are the required things? Sodium oxalate solution is required for standardization. Then 0.1 normal Fe2 ferrous ammonium sulfate solution is required. Unknown solution is required, that is persulphate solution, potassium persulphate, K2H2O8 solution, this is unknown solution. Phosphoric acid solution is required, this is phosphoric acid. Dilute H2SO4 is also required, so this is dilute H2SO4. KMnO4 solution is required, this is 0.1 normal KMnO4 solution which is filled in the burette. The procedure is divided into three parts. First part is standardization of 0.1 KMnO4 solution. For that purpose we have to titrate sodium oxalate solution against KMnO4 solution. Second part is main estimation part, and third part is blind titration. Let us start with the first part, that is standardization of 0.1 KMnO4 solution. We have to pipette out sodium oxalate solution. This is sodium oxalate solution. 10 ml solution has to be pipetted. I have taken out this solution in the beaker. Now I am pipetting 10 ml solution in conical flask. So this is 10 ml sodium oxalate solution. In this solution we need to add 1.5 test tube dilute sulfuric acid solution. So this is sulfuric acid. I am taking 1.5 test tube sulfuric acid solution. Now we have to heat this solution, and when that solution is hot, we have to titrate it against KMnO4 solution. Burette is filled with 0.1 KMnO4 solution. Burette is ready. Now we have to heat this solution for 50 to 60 degrees centigrade. Now we need to heat this solution for about 50 to 60 degrees centigrade, and then we have to titrate it against KMnO4 solution. To titrate this solution against 0.1 KMnO4 solution, addition of KMnO4 should be drop wise with constant shaking. We have to add KMnO4 drop wise with constant shaking. I am titrating this solution against 0.1 KMnO4, adding 0.1 KMnO4 drop wise with constant stirring. End point will be pink color, permanent pink color. The pink color should persist permanently. Now it is disappearing as soon as it is formed and solution is titrated. Now see, this permanent pink color is obtained. This is the end point of the titration. Now I am stopping addition of KMnO4 solution. This is the permanent pink color. You can see it is not disappearing, and burette reading is, see the burette reading. This is 10.6, yeah, 10.7. Okay, so this is the standardization reading. We have to take 3 readings, and after taking 3 readings we have to report constant burette reading, okay, for standardization. Now second part of the procedure, that is main titration, that is estimation part. Unknown solution of persulphate is diluted up to the mark. From this solution we have to pipette out 10 ml solution in conical flask. Then we need to add 3 ml phosphoric acid, 5 ml sulfuric acid, exactly 25 ml 0.1 Fe2 solution, and then we have to titrate that solution against KMnO4. Now I have adjusted 0 level of KMnO4 solution. Okay. Now I am pipetting 10 ml sample solution. I am taking out this solution in one beaker. This is diluted persulphate solution. I am pipetting 10 ml solution. So this is 10 ml sample solution which is pipetted in the conical flask. Now in this solution we have to add 3 ml phosphoric acid and 5 ml sulfuric acid with the help of measuring cylinder. This one is phosphoric acid, 85% phosphoric acid. We need to take 3 ml phosphoric acid. Now I am taking this phosphoric acid very carefully. Phosphoric acid I am taking now in the conical flask with the help of measuring cylinder. Then we need to take 5 ml sulfuric acid. This is dilute sulfuric acid. Five ml dilute sulfuric acid is required to be added, and then exactly 25 ml Fe2 solution has to be taken. This is 0.1 Fe2 solution. Now I have to take exactly 25 ml solution. I have to take out it in a small beaker. Now I need to pipette out 25 ml solution. I am pipetting 25 ml solution. This is 25 ml solution. See, all these reagents are mixed in the conical flask. We have to shake this solution properly, and then this solution has to be titrated against KMnO4 solution. 0 level is adjusted. Now I am titrating this solution against 0.1 KMnO4 solution. Okay, I am titrating this solution. Titration is continued till we get permanent pink color. Now this pink color should persist. It is disappearing. End point is very close now. See the color of the solution. Yes, pink color. This is permanent pink color. This is the end point of the titration. This is end point of the titration. This is permanent pink color. You can see the burette reading. It is 19.5, approximately 19.4 and 9.5. Okay. Likewise, we have to go for 2 more readings, and after taking 3 readings, we can find out constant burette reading. Now, third part, that is blank titration. In blank titration, we don't have to take sample solution. K2H2O solution is not to be taken. We don't have to take sample solution. The rest of the solution has to be taken, and then that solution can be titrated against KMnO4 solution. Now, what are the other solutions? We have to take exactly 25 ml Fe2 solution. Okay. Then phosphoric acid has to be added, sulfuric acid has to be added, and then we can titrate that solution against KMnO4 solution. Let us start this third type of titration. Now I have to pipette out 25 ml Fe2 solution. I am pipetting 25 ml Fe2 solution. So this is Fe2 solution. 25 ml Fe2 solution. I have to take phosphoric acid solution. I am taking 5 ml phosphoric acid solution. This is 5 ml phosphoric acid, and then 10 ml sulfuric acid has to be taken. This is dilute sulfuric acid. I am taking 10 ml solution. So 10 ml sulfuric acid is added. and this solution has to be titrated against KMnO4 solution. I have adjusted the 0 level of KMnO4 solution, burette solution. Now I need to titrate this solution against KMnO4 solution. Now KMnO4 has to be continued with constant stirring, dropwise with constant stirring till we get permanent pink color. I am titrating that solution. This is the blank titration. No sample solution is to be taken in case of blank titration. The rest of the solutions has to be taken other than sample solution. So no K2S2 is taken. So end point will be again permanent pink color. This is permanent pink color. See, this is the end point of the titration, right? Permanent pink color is the end point of the titration, and burette reading is somewhere 23 ml. Okay, 23 ml is the burette reading. We have to repeat the titration 2 more times so that we can report constant burette reading. Okay. Now reading part is over. From the standardization part we can calculate the normality, exact normality of KMnO4 solution, and by taking the difference between these two reading, that is main estimation and blank reading, we can find out amount of KMnO4 which is consumed by persulphate solution, and by using reaction stoichiometry it is possible to calculate amount of persulphate which is given in the unknown solution. Okay, thank you.